Hello, everyone. I'd like to thank all of you for taking the time to join me for this presentation today. My name is Yihua Liu. I'm a SETA contractor serving as a data scientist with the Advanced Distributed Learning Initiative, or ADL. ADL is a component of the U.S. Department of Defense that focuses on training and education. And our primary stakeholders include the U.S. Armed Forces and other DoD organizations. This presentation will focus on the use of metadata in e-learning, but we won't just examine the status quo. We'll also look at some of the exciting research that ADL and other folks are doing to expand current boundaries and facilitate greater functionality, flexibility, and interoperability through metadata. So to begin, let's look at where we came from. We're all very familiar with the traditional model of education. You have a bunch of students in a classroom, taught by an instructor going through a predefined curriculum. There's very little flexibility. You have to be in a certain place at a certain time, and you have to go at the pace the instructor chooses. But on the other hand, distributed learning allows students to learn anytime, anywhere, and at their own pace. It can employ a variety of digital learning resources, such as online videos or ebooks, and many different modalities, such as e-readers, mobile devices, or simulators. And all these systems generate huge quantities of data, which can be tremendously useful for data scientists, educational administrators, and instructors. But to make the most of these huge data sets, we need to enable these systems to communicate with each other. They need to be able to send, receive, and most importantly, understand the data produced by different services in a learning ecosystem. That is what we call interoperability. One key step in facilitating interoperability is the use of technical standards and specifications. Now, you may be familiar with standards bodies like ISO and IEEE, which maintain a ton of standards used across many fields. E-learning is certainly one of those fields, and within e-learning, standards such as learning object metadata, or LOM, and reusable competency definitions, or RCD, established consistent protocols that allow different learning resources to communicate with each other. And we'll come back to some of these specific standards a little bit later. But first, what is metadata? Well, it's data that describes other data. For example, an online video is itself data, but the file may include metadata about itself, such as its duration or video resolution. Another common example is most websites. They include tags that help search engines and other pages determine what the site is about. And here's a visual example. This is a screenshot I took when searching for shirts online. You can see how this retailer allows you to filter by color, size, price, and so on. And this is one of the most prominent uses of metadata, what we call search and discovery. I mean, can you imagine how much harder it would be to find the kind of shirt you were looking for if they didn't allow you to filter by this kind of information? So in distributed learning, metadata can be included with all kinds of resources, such as the ones you see here. And in the past, it was most commonly used just to aid search and discovery. For example, if you're an instructor teaching high school algebra and you want to look for educational resources, you want to find content for the appropriate course and difficulty level. You don't want to find stuff for college level abstract algebra, let's say. But there's much greater potential than just the basic descriptive use case. And these are some of the frontiers we're beginning to explore. For example, it can enable automation of labor-intensive processes. One prominent example of this came up recently with the deprecation of Adobe Flash. Now, Flash was widely used in distributed learning for many years, but very soon, at the end of this year actually, Adobe will stop supporting Flash. So many organizations will have to convert or remake their Flash material, and metadata can help identify duplicates, which can save a lot of time and money. Of course, there's also the rapidly evolving field of artificial intelligence. We have data now of greater quantity, quality, and precision than ever before. And although it's way too much for humans to parse, it's certainly great for AI. And we can obtain greater insights into learning and enable things like intelligent tutors and recommender systems to personalize the learning experience and optimize learning paths. And beyond that, who knows what the future will hold. AI and big data are rapidly evolving, so it's very exciting to see what new developments may arise in the future. So how can organizations best take advantage of these advanced capabilities? Well, one key thing is that they must have a metadata strategy. At the top of this slide, you can see just some of the factors that go into the process of designing a metadata strategy. All of these huge data sets have to be appropriately managed from beginning to end, and it's important to consider not only your current needs, but to prepare for the future as well. These are some of the questions an organization must answer. For example, commercial enterprises, educational institutions, and government entities all have different priorities, and these priorities will determine their data needs. Similarly, newer learning modalities like virtual reality require a different approach from web-based courseware delivered through an LMS or learning management system. And how many individuals do you have to worry about? Are we talking about a young startup with maybe a dozen employees, or the DoD, which has 3 million employees? You can see how this isn't something you can just copy and paste. Everybody's solutions will look different based on these considerations and others. Now, we mentioned standards a little bit earlier and how they played a big role in a learning ecosystem. So let's look at some of those in more detail. One of the main motivations behind metadata standards was to allow communities of practice to communicate more easily within their fields. For example, when you take a photograph, most digital cameras will include metadata with information such as the model of the camera, the photographic exposure information, and the time the picture was taken. How do we ensure that a device can correctly interpret metadata created by another device? Well, by having a standard. The most commonly used metadata standard here, which some of you may be familiar with, is something called the Exchangeable Image File Format, or EXIF, EXIF. This format is maintained by several organizations across the industry to ensure that a digital photograph's metadata can be read and interpreted the same way across various operating systems, camera models, and graphics editors. And as you can see, the metadata standards are a crucial step toward long-term interoperability. This is also key for any work you might look to do with AI. Standards will help ensure that training and education data can be read and interpreted by any AI solution across the DoD, instead of requiring custom integration into each different component. So in the realm of distributed learning, we have several metadata standards that have been widely adopted across the industry. Two of the most prominent ones are LOM, an IEEE standard, and LRMI, which is under the stewardship of the Dublin Core Metadata Initiative. Now, these standards are not by any means bad or obsolete. In fact, they're quite well suited for traditional distributed learning, which centers on a learning management system. But as we've discussed, distributed learning has evolved, and there are many different types of learning activities now that weren't as prevalent when these legacy standards were designed. Nowadays, for example, with mobile technology, a learner might log into an online course on many different platforms and for varying durations. And we see all kinds of organizations beginning to recognize that learning is not just something that stops once a student graduates. They're beginning to emphasize training and education throughout a person's career, and indeed throughout a person's life. So a future learning ecosystem will rely on the availability and accessibility of personalized longitudinal learner data that may reside across institutional boundaries. One example of such a system is ADL's Total Learning Architecture, or TLA. This is a framework of standards and specifications, and the goal is to facilitate plug-and-play interoperability for learning technologies, meaning you don't need to be locked into a specific software or vendor, and you can have flexibility in how to structure your own implementation to best suit your needs. The 4 pillars of the TLA are 4 commercial standards we see here. The first one is the Experience Application Programming Interface, or XAPI. This is a data format based on JavaScript Object Notation, or JSON, that captures learning activity streams. XAPI enables very detailed data about learner behavior, which is key for things like AI. The second is a new learning metadata standard which builds on legacy standards, seeking to harmonize them and upgrade them to better accommodate newer learning modalities. Third is RCD, which defines the structure of a competency and how they relate to each other. This is key for personalized competency-based learning. The fourth has to do with learner profiles, which hold information about the learners themselves. And we'll come back to each of these in more detail soon. But first, at a high level, what are some of the benefits of this type of architecture? Well, of course, one is semantic interoperability, which we've already mentioned a few times now, allowing services to securely discover and communicate with each other. It also separates out various functions usually performed by an LMS, which improves scalability and allows the same metadata to be used for multiple purposes. For example, one learning tool may calculate the gaps between a learner's selected goals and their current competency levels, while another component can determine the most efficient learning path to the goal. So let's dig deeper into the four pillars we just talked about. The first one, XAPI, is used to capture data about learner behavior. If any of you are familiar with learning management systems running old SCORM content, you may have seen some of the basic information that was captured before, like, for example, when a student starts or pauses a video or completes an assessment. But XAPI statements are very flexible and can capture even highly detailed things like biometrics, for example, tracking heart rate or eye movements. An XAPI statement has only 3 required fields, the ones you see here, actor, verb, and object, and many optional ones like result and context. So let me show you a few diagrams to help visually demonstrate what's going on here. And please feel free to pause on any of these if you'd like more time to get a closer look. This picture illustrates the flow of XAPI data. You can see how several different systems are involved here and how each one of them uses the XAPI data a little differently. This figure shows how a learning activity can be instrumented to send XAPI statements to other learning systems. The key here is that each activity has a unique ID, which allows any system to retrieve that activity's metadata file. The XAPI profile specification details how to document the vocabulary concepts, extensions, templates, and patterns that are required for implementation. This diagram illustrates how an LRS, or a learning record store, reconciles the various personas a user may have across the learning ecosystem. For example, you may have numerous accounts across your job, your school, and your personal life, and you may learn on many different devices. The LRS can use the information from the XAPI statements and your own learner profile to tie them all back to you, while keeping track of each persona's behavior individually. The next pillar is the metadata for learning resources themselves. Now, the main standard that applies here is IEEE 2881, which just kicked off a few months ago. The foundation for this effort is based on research that ADL has been conducting on existing standards, such as LOM and LRMI, which we mentioned earlier, and also on conversations with various DoD stakeholders about what gaps they needed to fill. And 2881 is not formally associated with any of these existing standards, but it does build upon them while incorporating new fields to enable more precise data collection. Another key feature will be the differentiation between different types of learning resources. So this diagram shows the relationship between types that we're now calling experiences, activities, content, and courses. This is important because, for example, different attributes apply to different types. Physical location, for example, may be an essential characteristic for a live field exercise activity, but it may not be applicable to a textbook or online video used as part of that activity. So we're differentiating between the activity, which is the context, such as a simulator, LMS, or classroom lecture, and the content, which is the digital artifacts used in that activity, such as a simulator scenario or a technical manual. We're also looking at the distinction between metadata, which is usually created during the development of instructional activities, and paradata, which is data about activity usage and can be dynamically updated. For example, one such attribute could be the average rating of a course, let's say 1 star through 5 stars, from students who have completed it. And in many cases, this information does already exist, but it can be locked away in disconnected proprietary data silos. So for DoD, we're aiming to be able to pull everything into a single location to create a department-wide network. Next are the competencies themselves. Of course, you can't have competency-based learning without an agreed-upon way to define competencies and how they relate to each other. And that's where the RCD standard comes in. The goal behind competency-based education is to focus on specific knowledge, skills, aptitudes, and other traits that will grant proficiency at a certain job or task. And the evidence of mastery from various sources weighted based on the authority and trustworthiness of those sources. A competency framework is what defines that structure. RCD standard uses linked data to define all aspects of a competency, including key performance indicators, formal assessments, and other measures of proficiency, and how competencies relate to each other within a framework. For example, one may be a prerequisite to another, or two separate ones may encompass a third one. This relates back to what we were talking about because competency models are almost entirely made of metadata. Some RCD attributes, like the description field, are designed to be human readable, while others, like language, must follow strict guidelines to ensure machine readability. And this is where linked data comes in. It enhances semantic precision. The use of globally unique IDs accounts for the possibility of identical competencies with different titles or descriptions across systems. This diagram here shows how these different objects relate to each other in the RCD standard. You can see many of the different elements of a competency framework and how they interact with each other. Finally, the last pillar is the learner record. Now, although they aren't commonly thought of as learning resources, learners themselves are the centerpiece of a future learning ecosystem. After all, the whole idea is to shift the attention from the classroom to the individual. This requires a lot of data about the individual to tie everything together. As we saw above, we could be dealing with numerous accounts, platforms, and devices. And most of us are familiar with transcripts, which are widely used by academic institutions, but the information they contain is usually very limited. I mean, you spend an entire semester taking a course, and the whole picture of your learning experience can be summarized by a single letter? I mean, probably not, right? Transcripts usually lack a lot of important details, like the ones you see at the bottom of this slide. And that kind of information is exactly what we need to offer better personalized instruction. Right now, for example, your educational history likely lies in many different institutions, and it would be extremely tedious to get all of it in one place. If you imagine, for example, applying to grad school, you may need to request transcripts from several different schools that you've previously attended. And even then, that wouldn't cover any training you may have had at a particular job, or certificates or credentials you may have earned on your own. So the goal is to store an individual's learning history, their goals, their preferences, their credentials, and so forth in a single place, something they can take with them wherever they go. And of course, with privacy and security of utmost importance. Right now, there are several ongoing efforts to harmonize credentials from numerous trusted sources, which can then be decomposed into competencies using something called the Credential Transparency Description Language, or CTDL. And of course, these assertions of competence require trusted evidence. I shouldn't be able to just say that I'm a brain surgeon or a nuclear physicist and get away with that without any proof. So a learner profile must have an auditable chain of evidence, which can include a continuous ledger of all learning activities they encountered, along with the unique activity IDs, the competency IDs, and a pointer to the evidentiary XAPI data. So the goal is to develop a learner profile that works with the other components we've discussed to tie everything together in one place securely. Now, to summarize, the primary motivation behind this research is to expand the idea of learning from just formal education, where you go to school for a number of years, you get a degree, and then you stop learning. Expand it from that to lifelong learning, which is much more reflective of today's environment, where not only are learning resources more accessible than ever before, but there's also a greater demand, a greater need for people to continuously expand their skills and knowledge, even in the workforce. And because of that, we need to be able to bring data together from many different sources. Right now, for example, in the DoD, training and education records are scattered across numerous systems, and they exist in a bunch of different formats. So it must be a priority to enable these systems to communicate with each other to form a complete picture of an individual's learning path, especially learning events that have traditionally been difficult to measure and record, like mentorship, on-the-job training, and apprenticeships. And that forms the high-level picture of our next steps from here. So first of all, we have to be thinking about taking things from disconnected proprietary data silos to interconnected, interoperable systems. We also, of course, have to refine strategies for working with data across technological and organizational boundaries. And finally, of course, we have to continue to improve processes around transport, control, management, governance, and ownership of data. Now, thank you again, everyone, for viewing this presentation. I really enjoyed recording this talk, and I hope you've been able to learn a few things today. My contact information is on the front page of the paper, and as I mentioned, these are ongoing efforts, not solved problems. So please don't hesitate to reach out to us if you have any questions or comments, or especially if you'd perhaps like to get involved in some of these working groups or know someone who might. We certainly encourage public participation, and we love to hear feedback from the community. So please don't be shy about reaching out to us if you're curious about how you can join some of these discussions. So again, I appreciate your time, and I hope you enjoy the rest of Virtual ITSEC 2020.